Kids maybe already know this, but we've been talking about how orbital forcings start the cooling or the warming and the buildup of the glaciers or the retreat of the glaciers with our famous ice albedo feedback. So, there we saw that warming or cooling was ahead of CO2 increase or decrease. So if glaciers melted away, CO2 would increase and warming would be starting that whole process. And the other way, if you're building glaciers, the cooling will start first, glaciers will build, and then CO2 will decrease. But now we are saying CO2 is increasing because of our fossil fuel burning, and that's what is causing temperature increases and global warming because CO2 is a greenhouse gas. So, how did we flip this? Well, first of all, we know from measurements that CO2 is increasing. We know from measurements that global mean temperatures are going up. Now we have to prove that the CO2 is actually causing the warming, which is easy enough using our fundamental greenhouse gas effect principles. But now you have to show that the CO2 increase is actually coming from burning fossil fuels, because not everybody just believes it when you say CO2 increase is coming from fossil fuel burning, which is what we are doing. So for that, we use carbon isotopes and other isotopes, as you already know. If you don't know what isotopes are, don't worry about all that. But remember, fossil fuels are hydrocarbons, which means they were photosynthesized materials that got buried and got converted into gas, oil, or coal. And what happens during photosynthesis? Obviously, plants take up CO2 in the presence of sunlight to combine with water and use the energy to produce carbohydrates. There are some details. You need chloroplasts to do that. But that hydrocarbon is formed by taking up CO2, but plants are trying to save energy, so they take more of the lighter CO2, so 12 carbon CO2 instead of the 13 carbon CO2. Both 12 and 13 carbon are present in the atmosphere. So the more the photosynthesis producing carbohydrates, the more the C12 carbon in the plant material that's converted to fossil fuel. So there is depletion of C13 in that, and when we burn it, we put all that C13 depleted CO2 into the atmosphere, so we can measure CO2 just like Charles Keeling did and look at the isotopic content and see that it's more and more depleted in C13, and hence it's coming from fossil fuels.